Today we are going to see stoichiometric calculations. I'm going to write an equation for the combustion of methane. Methane plus oxygen. Combustion means heating in the presence of oxygen. Methane plus oxygen. The products are carbon dioxide plus water. And when you balance the equation, we get methane plus 2O2 gives CO2 plus 2H2O. And all the reactants as well as the products are in gaseous state. Now, if you look at this equation, you can see numbers written on left hand side of the formula. You can see before methane, there is no number written, it means 1. Now, before O2, 2 is written. CO2, no number, which means it is equal to 1. And before H2O, the number 2 is written. These numbers, which are written before the formula of the compound, is known as stoichiometric coefficients. Now, there are many informations that we get by looking at the stoichiometric coefficients. So, I am going to write the different informations that you get by seeing the stoichiometric coefficients in a chemical equation. That is, in a balanced chemical equation. Now, the first information that we get is the stoichiometric coefficient gives us information about the number of molecules that participate in chemical reaction. That is, if you look at this example, there is combustion of methane, we can say that 1 molecule of methane combined with 2 molecules of oxygen to give 1 molecule of carbon dioxide plus 2 molecules of water vapor, that is H2O, up arrow denotes steam. So this is the first information that you get from the stoichiometric coefficient. It gives us the number of molecules participating in a chemical reaction. Now the second information is we get to know the number of moles of substance in a chemical reaction. So this is the first information, that is the number of molecules. Now the second information is number of moles. So if you look at this equation, I can write 1 mole of methane combined with 2 moles of oxygen to give 1 mole of carbon dioxide plus 2 moles of water vapor or steam, H2O. So this is the second information. Now the third information is we get to know what mass of reactants combine to give what mass of products. So the third information is the mass of reactants and products. Now, we have to calculate the molecular mass to get the masses of reactants that combine. Methane, molecular mass is methane, atomic mass of carbon is 12, hydrogen 4 atoms, so 4 into 1, which is equal to 16 gram. Now, O2, oxygen atomic mass is 16, O2 means 32, 32 into 2, this 2, 32 into 2 will be 64 gram. Now carbon dioxide 12 plus 2 into 16, which is equal to 16 into 2, 32, 32 plus 12 will be 44 gram. And H2O, the molecular mass, H2O is 2 H2O, so 2 into 18, which is equal to 36 gram. So in terms of mass, I can write Methane, molecular mass is 16 gram. I can write 16 gram methane combined with 64 gram oxygen to give 44 gram carbon dioxide plus 36 gram H2O. So this is the third information. We get to know about the masses of reactants and products in the chemical reaction. Now the fourth information is, since all the reactants and products in the combustion of methane are in gaseous state, we can write the volume of reactants used and the volume of products formed if you look at the stoichiometric coefficient. So here you can see 1 volume of methane combined with 2 volumes of oxygen to give 1 volume of carbon dioxide plus 2 volume of water vapor. So on the basis of volume, I can write 1 volume of methane combined with 2 volumes of oxygen to give 1 volume of carbon dioxide plus 2 volume of water vapor. Now, the last information that I can write is, we know that 1 mole of any gas occupies 22.4 liters at STP, that is standard temperature and pressure. So, if you know the volume, you can write what is the volume occupied by these gases. So, 1 volume of methane means it occupies 22.4 liters at STP. So, I can write 22.4 liters of methane combined with 2 volumes of oxygen means I can say 2 into 22.4 liters of oxygen, which is equal to 44.8 liters of oxygen to give 22.4 liters of carbon dioxide plus 2 volume of hydrogen, which means again 44.8 liter of water. So these are the different information that we get if you look at a balanced chemical equation. And these informations are given by the stoichiometric coefficient. So the informations are, the first information is we get to know the number of molecules. Second is the number of moles. Third is the mass of reactants and products. Now 4 is the volume of the reactants and products if the reactants and products are in gaseous state. And last you can write what volume is occupied in terms of liters. So these are the different informations. Now next I am going to discuss a term called limiting reagent. Limiting reagent. Now, in some chemical reactions, one of the reactants will be in excess than the other. Now, the reactant which is present in lesser amount will be consumed first, and after that, no further reaction takes place. So, the reactant which is consumed first will limit the amount of product formed, and we call this reactant as a limiting reagent. And the other reactant is known as excess reactant. And excess reactant will not undergo any further reaction, because once the limiting reagent is over, then the other reactant will be in excess. After that, no further reaction takes place. So this is called a limiting reagent. Now, stoichiometric calculations and limiting reagents are used in problems. So we are going to do 3 problem questions. Now look at the first question. Calculate the mass of hydrochloric acid required to neutralize 2.5 gram of sodium hydroxide. The mass of hydrochloric acid required to neutralize 2.5 gram of sodium hydroxide. Now, in any stoichiometric calculations, First, we have to write the balanced chemical equation. So here you can see the reaction is between hydrochloric acid and sodium hydroxide. I'm going to write the balanced equation. That is NaOH plus HCl. You know that acid and base reactive form, salt and water. So NaCl plus H2O. Now, the question is, calculate the mass of hydrochloric acid required to neutralize 2.5 gram of sodium hydroxide. So, the mass of sodium hydroxide 2.5 gram is given, and you have to find the mass of hydrochloric acid required to neutralize 2.5 gram of sodium hydroxide. So, first we will write, according to this balanced equation, what mass of sodium hydroxide or what mass of hydrochloric acid is required to neutralize what mass of sodium hydroxide. Now, if you look at this equation, sodium hydroxide, the molecular mass of sodium hydroxide, sodium atomic mass is 23 plus oxygen is 16 plus 1, which is equal to 40 gram. Now, hydrochloric acid 1 plus 35.5, which is equal to 36.5 gram. So, according to this balanced equation, I can say 40 gram NaOH requires 36.5 gram hydrochloric acid. Now, the question is, what mass of HCl is required to neutralize 2.5 gram of sodium hydroxide? Therefore, 2.5 gram sodium hydroxide will require X gram hydrochloric acid. Now here you can use the unitary method. Unitary method means you can solve for X. Now how will you solve for X? X will be equal to, X is equal to 36.5 into 2.5 divided by 40, and the answer is 2.28 gram. So we can say 2.28 gram of hydrochloric acid is required to neutralize 2.5 gram of sodium hydroxide. So this is the answer, 2.28 gram. Now the second question, calculate the volume of water vapor formed when 225 ml of methane is oxidized completely. So first we have to write the balanced equation. Now here is oxidation of methane or combustion of methane. So the balanced equation I'm going to write. The balanced equation is methane plus 2O2 gives carbon dioxide plus 2H2O. Now, the question is to calculate the volume of water vapor formed. Water vapor volume you have to calculate of water vapor formed when 225 ml of methane is oxidized completely. So, we can say, according to the balanced equation, we can say that 1 volume of methane will give 2 volume of water vapor. Now, the question is, when 225 ml of methane is oxidized completely, what volume of water vapor is produced? So, 225 ml of methane will give X ml of water vapor. Therefore, you can calculate X. X will be equal to 225 ml into 2 volume divided by 1 volume, which is equal to 450 ml. So we can say on combustion of 225 ml of methane, we get 450 ml of water vapor. Now, next question, question number 3. 4.6 gram of sodium is reacted with 2500 ml of chlorine gas. So the reaction is between sodium and chlorine gas, and we know the product formed is sodium chloride. If all the sodium is used in the reaction, calculate the volume of chlorine used. If all the sodium is used in the reaction means we know from this that sodium is the limiting reagent and chlorine is in excess. Okay, so first the balanced equation we are going to write. The balanced equation is sodium and chlorine. So 2Na plus Cl2 gives 2NaCl. Now 4.6 gram of sodium is reacted with 2500 ml. Now if you look here, this is the mass and this is the volume because chlorine is a gas. And sodium mass 4.6 gram is given. So again here when you write according to the balanced equation, sodium you have to write in terms of mass and chlorine in terms of volume. So sodium atomic mass is 23. We have 2 atoms of sodium. So 2 into 23 which is equal to 46 gram of sodium will react with. Now here we have 1 mole of chlorine gas. 1 mole because the stoichiometric coefficient here is 1. And we know that 1 mole of any gas occupy 22.4 liters. Convert it into milliliter because it is given 2500 ml of chlorine gas. So convert 22.4 into milliliter, we get 22400 milliliter of chlorine. So according to balanced equation, we can say 46 gram of sodium combined with 22,400 milliliter of chlorine. Now, the question is, what 4.6 gram of sodium is reacted with this much chlorine? If all the sodium is used, calculate the volume of chlorine used. So we have to calculate the volume of chlorine used when 4.6 gram of sodium is reacted. So next step will be 4.6 gram of sodium will combine with what volume of chlorine? X ml of chlorine. So now you calculate X. X will be equal to 4.6 gram into 22,400 ml divided by 46 gram. Gram and gram gets cancelled and you get the answer as 2240 ml. 2240 ml. So, if you look at this question, you can see if all the sodium is used in the reaction, which means sodium is the limiting reagent, calculate the volume of chlorine used. So, we can say out of 2500 ml, we used only 2240 ml of chlorine gas to react with 4.6 gram of sodium. So what is the excess of chlorine left? Chlorine is in excess now. So chlorine, excess of chlorine present or left. Will be equal to 2500 minus 2240, which is equal to 260 ml. So we can say 260 ml of chlorine is left unreacted and sodium is the limiting reagent. So these are stoichiometric calculations. Always we have to write the balanced equation and according to the question we have to find out. Okay. Now the next thing coming in this chapter is reactions in solutions or terms for expressing concentration of a solution. Now, what do you mean by concentration of a solution? Concentration of a solution is the amount of solute present in a known amount of solvent. Now, any solution you take, there will be 2 components present in a solution. The first component is called solvent and the second component is solute. These are the 2 components present in any solutions. Now, solvent is denoted by capital A or 1 and solute is denoted by capital B or 2. Now, what do you mean by binary solutions? Binary solutions mean solutions which consist of only two components, that is one solute and one solvent. That is a binary solution. So, we are going to discuss about solutions expressing the concentration of a solution. Now, there are 5 important terms to express the concentration of a solution. So, when we study the concentration terms used to express the concentration of a solution, we always have a solute and solvent in that solution. And we are going to deal only with binary solution. Binary means one solute and one solvent. Okay. Now, we know what is solute and solvent. Solvent is the component present in larger amount and solute is the component present in smaller amount. And for example, sugar solution. In sugar solution, we have sugar dissolved in water. So, sugar is the solute which is present in smaller amount and solvent is water which is present in larger amount. Now, we are going to see the different concentration terms. I told there are 5 concentration terms to study the concentration of a solution. We are going to see each term in detail. The first concentration term is mass percentage. Mass percentage. Mass percentage, the definition is, it is the mass of a component dissolved in 100 gram of solution. Mass of a component. When I say component, it can be solute or solvent present in 100 gram of solution. Now, if you write the expression for mass percentage, suppose you are writing the expression for mass percentage of solvent. Mass percentage of solvent. Solvent is denoted by capital A is equal to mass of solvent. Mass of solvent A divided by total mass of solution. When I say total mass of solution, solution has solute and solvent in it. So, total mass of solution means mass of solvent A plus mass of solute B into 100. So, this is the expression to find the mass percentage of solvent. Now, suppose we want to find the mass percentage of solute, then the expression will be mass percentage of solute. Solute is denoted by capital B is equal to mass of solute divided by total mass of solution, which is equal to mass of solvent plus mass of solute into 100. So, this is the expression to find mass percentage. Now, example, suppose you see 10% glucose solution by mass. What is the meaning of this sentence? 10% glucose solution by mass. It means that 10 gram of glucose is dissolved in 90 gram of water. So that the total mass of the solution is 100 gram. Okay, now next example. 68% HNO3 by volume. What is the meaning of this sentence? 68% nitric acid by volume. By volume means 68 ml of nitric acid is dissolved in 100 minus 68, which is equal to 32 ml of water. So that the total volume of the solution is 100 ml. So this is actually mass not mass percentage, this is volume percentage, because it is 68% nitric acid by volume. So the percentage can be in terms of mass or in terms of volume. Suppose you are asked to prepare 95% ethanol. We know ethanol is an alcohol and is a liquid. So here we have the volume percentage. So what do you mean by 95% ethanol? How will you prepare 95% ethanol? Take 95 ml ethanol. To this add 5 ml water, so that the total volume of the solution is 100 ml. So this is mass percentage and volume percentage, the first concentration term. Now the second concentration term is mole fraction. Mole fraction, denoted by X. Now the definition of mole fraction is, it is the ratio of number of moles of a particular component to the total number of moles of all the components present in the solution. So we have mole fraction of solvent and mole fraction of solute, and the expression is mole fraction of solvent denoted by XA is equal to, the definition is, it is the ratio of number of moles of each component to the total number of moles of all the components present in solution. So XA will be equal to, it is number of moles denoted by small n. So XA is equal to Na divided by total number of moles of all the components. So we have component, solute and solvent. So Na by Na plus Nb. This is the expression to find the mole fraction of a solvent. Now the expression to find the mole fraction of a solute is Nb by Na plus Nb. And this is a dimensionless quantity, means no unit for mole fraction, as this is the ratio. Now in binary solution, we can say the sum of mole fraction of all the components is equal to 1. So binary solution means we have only two components, solute and solvent. So in binary solution, the sum of mole fraction of solute and solvent is equal to 1. That is XA plus XB is equal to 1, or XA. If you want to find XA, if you know XB, it is 1 minus XB, which means if there are I components, I number of components in a solution, we can say the sum of mole fraction of all the components, that is XA plus XB plus XC plus XD plus etc. to XI will be equal to 1. It is equal to unity. Now, you know how to find Na and Nb. What is the expression to find the number of moles? Number of moles is given as Na is equal to Wa by Wb. It is given mass by, Wa by Ma, molar mass. And the expression to find Nb is equal to Wb by Mb. It is given mass by molar mass of solute, and Na is given mass by Ma. Ma is the molar mass of solvent. So these are the different expressions used to find the mole fraction. Now next we have a problem question based on mass percentage and mole fraction. The first question is, calculate the mass percentage of benzene and carbon tetrachloride if 22 gram benzene is dissolved in 122 gram carbon tetrachloride. You have to find the mass percentage of benzene. And if you know the mass percentage of one component, the other component you can find by subtracting it from 100. So I am going to find the mass percentage of benzene first. So benzene. First, let's write the expression mass percentage of benzene. Formula of benzene is C6H6 is equal to mass of benzene divided by total mass of solution, means mass of benzene plus mass of CCl4 into 100. And here the mass of benzene and CCl4 is given in the question, that is 22 gram benzene and 122 gram CCl4. So substitution. Benzene is 22 divided by 22 plus 122 into 100, and we get the answer as 15.2%. This is the answer. Now, if you get the mass percentage of benzene, you can find the mass percentage of carbon tetrachloride. Mass percentage of CCl4. Now, it will be either you can use the expression, that is mass of CCl4 divided by mass of benzene plus mass of CCl4 into 100, or you can subtract from 100. So, this will be 100 minus 15.2, which is equal to 84.8%. So, we get the mass percentage of CCl4. Now, the next question is, calculate the mole fraction of ethylene glycol in a solution containing 20% ethylene glycol by mass, and the molecular formula of ethylene glycol is C2H6O2. So you have to find the mole fraction of ethylene glycol, and the expression to find mole fraction is X ethylene glycol C2H6O2 is equal to number of moles of ethylene glycol C2H6O2 divided by number of moles of ethylene glycol plus number of moles of water. That is the number of moles of component divided by total number of moles of all the components present. Now here you have to find the number of moles. Number of moles, to find number of moles, the expression is N, I am writing A stands for ethylene glycol, Na, actually it is NB because water is the solvent. As no solvent is given, water, we can take water as the solvent. So NB will be equal to WB divided by MB. Now, here NB, WB, what is WB? It's given in the question, solution containing 20% ethylene glycol by mass. So what's the meaning of that? 20% ethylene glycol by mass. It means that 20 gram ethylene glycol is dissolved in 80 gram water. So that total mass of the solution is 100 gram. Now here WB will be 20 gram and WA is 80 gram. Now you have to find NB first. So NB is equal to WB by MB. WB is 20 gram. Now you have to find MB, that is the molecular mass of ethylene glycol. So let's calculate the molecular mass of ethylene glycol. MC2H6O2. Atomic mass of carbon is 12 into 2 plus 6 into 1 plus 2 into 16. And the answer is 62 gram per mole. So 20 divided by 62 gram per mole. Gram gets cancelled and you get the answer as 0.322 moles. So this is the number of moles of ethylene glycol. Now you have to find Na. So Na next, that is NH2O, will be equal to WA by Ma. WA is 80 gram and molecular mass of water is 18 gram per mole, which is equal to 4.44 mole. So you got Na and Nb. Now we can substitute the expression for mole fraction. So X of C2H6O2 will be equal to 0.322 divided by 0.322 plus 4.44, which is equal to 0.068. Now you got ethylene glycol mole fraction. So now you can find the mole fraction of water. So XH2O will be equal to 1 minus 0.068 because we know XA plus XB is equal to 1. So this will be equal to 0.932 and no unit for mole fraction. So with this we finish two concentration terms in solutions. Thank you.